Hello class, this is lecture 4 and in this lecture we will be learning about arrays, graphs and cluster and how you can work around with them in LabVIEW. Uh-oh. Yeah. So starting with arrays, we know array is a collection of data elements that are all of same type. So we can have one dimensions or more dimensions in LabVIEW. So the way now each element in an array has a certain index through which you can access those elements. For example, this is a one-dimensional array having 10 elements. So each of them is indexed between 0 to n minus 1. Then going with creating arrays, array control and indicators. Okay, so let me demonstrate that to you. So you go to the front panel and then select data containers and then drop the array shell here. Now you can choose it to be an control or indicator depending upon what you put in here. So in the shell, if you put a numeric control, it's going to be a control shell. Or if you want an array indicator, then you have to again select another array shell, drop it here, and then put a numeric indicator. I mean you can have like even Boolean array. So you can even have like different data types like numeric, Boolean, string, or cluster. So right now we will be working mostly with the numeric arrays, but you can even explore the other kind of arrays as well. So this is right now a one-dimensional array. So you can add another dimension. You can make it two-dimension, for example, by right-clicking this and say add dimension. So now this is your 2D array, and this corresponds to this element corresponds to the row index, and this corresponds to the column index. So you can manually also create an array. You can just expand this as much as you want. So I am creating an array with 4 rows and 2 columns. So I can manually insert values into this, like 1, 2, 3. Okay. Now you can just make it short and you have created your array now, but now you can access every element by changing the row, and you can access them with the row and column index. So now if I change the row element, yeah, you can see different numbers. Yeah, so that's how you do it. And you can even use indicator. So I'm going to add another dimension here. Okay. And then going back to the front panel. Yeah, you can, as you can see here, it's the same as the input. Sorry, just have to make it 0, 0. Yeah, see, we can display the array. Okay, so this was about creating an array, control and indicator, and how you can manually insert values into it, and how you can access those elements using by changing the index, and how to add dimension. So this we have studied so far. Now we will learn how to create array constants. So whenever you have to create constants, you always have to use the block diagram. You cannot create constants on the front panel. So you have to come here, click, do a right click, go to array, and then select array constant. Here you have the array constant. Now you can drop in the numeric. Okay, I want to create a floating point constant, for example. So I can just expand this, okay, the way I want it. And then I can change, double click on this and change the value. Okay, double click, change the value. Okay, I just want to create a 4-element array for now. So I'll minimize this. And of course, you can add element to it. Clicking here, add dimension. You can create a 2D constant as well. So right now I'm just creating a 1D array constant of floating type. Similarly, you can also create an array constant of the Boolean type. True constant. Then, yeah, you can expand as much you want and then make them the way you want it to be. Yeah. So this is our array constant, the Boolean numeric. You can have like integer and string as well. Now next is we are going to create array with loops. So let's create a structure, say a for loop. I'm just demonstrating the examples which are there in your manual. So you can have this loop count. I want to create a constant of maybe 5. Yeah. And let's say there's some code that is running, and for now I'm going to use a random number generator. Okay. And this can be just like your code, it's generating some kind of value. So the way you can create an array here is you can, we want a numeric indicator. So I'm going to go to data containers, array, and I want to have a numeric indicator here. Okay, just to say that it's an output. Now we are back to the block diagram. This is my, yeah, I want to indicate. So with the loop, the way you can create is suppose there's a function here, there's a piece of code that is generating some kind of output. So every time in each iteration, you can create an array and store those values, which is from each iteration, you can save the values in an array. So just let's say that's it's generating some number in each iteration, and we are connecting here. And as you can see here, this is an auto index tunnel. So in the last lecture, I told about the last value. So you have to go to the tunnel mode. There are three options like last value, indexing, and concatenating. So last value, if you just want to know the last value of the iteration, it will be a single scalar value. So if you want to show that, okay, you can choose that. But if you want to save the each value that is of the iteration, then you can go with indexing. So you're arranging a scalar into an array using this option. Concatenating, it applies to arrays. Let's say if there was some array, so you can just and the output is also array, so you can concatenate uh, each array that is the output of each iteration. I don't know how much sense I'm making, but as we work through the examples, you'll understand it. So let's say if it is a scalar value, you want to make an array out of it, one-dimensional array, you choose indexing, auto indexing. So now let's run this. Oh, yeah, because we have 5 iterations, we have 5 values. This is an array, and it's a one-dimensional array. Like if I go here, so I'll show you another example that would clarify how the difference between the last value um, and the auto indexing. That, so let's say this is I, and I'm going to create another array. So one thing is you can just copy paste here, Control C, Control V. So it's going to create another array. Okay, array 4. So when I connect this I to this array, right now it's in the auto index tunnel. Now, now suppose I am going to connect this to, okay, so I want to see the last value of it. The way I can do is I can go to the front panel and choose numeric indicator. Okay. So yeah, where is it? Yeah. So when I have to, when I connect this scalar to this I through this loop, so now it's giving me error because this is a, like, see this, you have connected two terminals of different types. These cannot be wired together because their data types do not match. The type of source is 1D array, and the type of sink is double. So this so it's saying that the source, sorry, okay, so the source is like an an array, and this is a scalar, so they cannot be connected. So you just have to right click and go to tunnel mode and choose last value. Now it will just show you the last value. Run this, go to the front panel. Yeah, see, so it's going to show me the last value of I, and it's going to show me this is an array having all the elements, all the numbers of each iteration. Yeah, so okay, so now we see that the numeric is showing me the last value when I have set the tunnel mode as last value, and for this array indicator I have set it as auto indexing, so it's saving the value of I in each iteration and generating it as an array. Okay, so far good. Now let's create a two-dimensional array. So how can we create a two-dimensional array? So all we can do is have another, for now I'm just going to delete this all, or maybe just add another example here. Okay, I'm just going to move this on the side. So we're going to implement a 2D array. So for a 2D array, like if you have done C programming before or MATLAB, you know that you need two loops to create a two-dimensional array. So going by that, we are going to have two loops here, and let's say we have 4. Tools, tools palette, and I'm just going to, so okay, there is a difference called own labels. And so own labels is this one, like for example, array 3, array 4. For these kind of indicators, you have like an own label. But for constants, you have to create a label here. So I am labeling it as rows. Put it in the auto mode. Okay. Then I'm going to put another for loop. Right click, create constant, and then I'm going to have like 6 columns, and I'm just again going to go to the tools palette and select text, drop it here, right columns. Okay, then turn it on again. Okay, so you can just move it, position it nicely. Now let's say you have some kind of function running here. Again, we'll just, to simulate that code, we are just going to use a random number generator between 0 and 1. So again, we are going to create a numeric indicator. Okay, data containers array. I'm sorry, it's becoming a little messy. Just bear with me. And I'm going to make it an indicator. So therefore, I'm going to drop indicators here. Okay. Now window show block diagram. So here's my array 5. I'm just going to move it here. Okay, now I'm going to connect this. So here, see here it's showing me error because the reason is window show front panel. Right now it's a one-dimensional array, but my code is written for two-dimensional things. So all you have to do is right click, add dimension. So when you make it 2D, automatically that error goes off. Can you see it? Yeah. And the tunnel mode is set to auto index tunnel. Okay. And now let's run the code and observe the can just drag it. See the elements. Okay. Yeah, that's it. It has 4 rows and 6 columns. Not beyond that. Yeah. And if you have to put now manually see any element with a certain row number and index, just shrink this back again. Make it to one element, and then you can just change it and then see this is the row number and this is the column number, so you can access with the index numbers. Okay, so that is done. And then so the loop count, let's go back to our manual because the rest of the things are really straightforward. So we have seen the 2D array, creating array constants, creating array with loops, and then the tunnel modes. And look here, this part. Now let's say we have a for loop which has a certain, the count terminal is set to a certain constant. But if we have an array which is being connected to the loop here, and it's in the index auto indexing mode. So whatever will be the array size, that will be set as the loop count. Now in this case, there was an array that was connected to this loop and the size was 10. So now it doesn't matter what value do you put in here, the count will be set to 10 and not 100. Now, if let's say if you have like multiple arrays being connected to this loop with this auto indexing tunnel, then the one with the lowest array size will be the count for the for loop. Okay, and then we have different kind of array functions. So the way you can access is through the yeah, show block diagram. So for example, you can access it here from the functions. So you can select array size, put in here, connect this. Uh-oh. Okay. And so this is my array and I'm going to measure the size of it. Oh, okay. So let's see. I'm expecting to see a size of 5. Let's see how much it shows. You see? So you get a size of 5. So in this way, you can measure the size of the one-dimensional array, or also a two-dimensional array when you connect it to that. In our case, array size, and then just right click, create indicator. Okay. You can just double click on this to see where it is on the thing. So it's saying that 4 by 6. So it has 4 columns, 4 rows and 6 columns, as you can see here. And then let's see the rest of the part. Okay. Now similarly, I think there's no need for me to demonstrate everything here now, because it's very straightforward. You can just use the functions palette, the same place where you found array size. You can find initialize array function, and you can create an array. You can give the dimension, size, and the data, so it will create an array of size of 3 elements, and with 4 as an element in it. Okay. Now you can also build an array. So you can give an input as using the build array function. So you can give input an array and also an element. So what happens is it concatenates it to it, the scalar value. Okay, so when you use a build array function and you have 2 array inputs, then you have an output like this. But if you want an output like this, like a 1D array, so you have to right click on this build array and choose the concatenate input option. So you get an output like this. Then similarly, you can get an array, you can use array subset function to extract a subset with an index value that is specified and the length of it. So it starts from 0, 1, 2. So it starts to create a subset from this element of index 2 with the length of 4. So 7 to 5 is the output here. Now, index array, so you can specify the index to access the values. Like if you remember, we just did something here in the front panel. We were able to set the row and index value and see the element here. So similarly, you can do it in the block diagram, which would be like an automated process. There's nothing like manual. You just have to enter the index that you want. Yeah, for the 2D array also, you can mention the row and column. The other part is the column. Here they did not label it, but this is the column. So you can specify the row and column, and then it will give you the sub array or a single element. If you just specify a row or a column, then it's going to give you a sub array. Yeah, this is very straightforward. The next topic is the polymorphism. So the LabVIEW numeric functions are polymorphic. This means that the input to these functions can be of different data structures, scalars, and arrays. For example, you can add a scalar to an array or add two arrays together. So polymorphism is like you can add two different data structures, like scalar, you get a scalar value. You have like a scalar plus array. So each of this element in an array is being added to here. And when you have like two arrays, the corresponding elements are being added. And then suppose you have arrays of different lengths, then what happens is you get the resulting the resultant is an array with the length of the lowest with an array of the lowest length, sorry. So you have like a 3-element array and a 4-element array, but the result will be a 3-element array here. And also you can give like, you can generate an array. So here there's an array being generated of length 100. So each element will be multiplied by a certain number when you're using a function like this. So here's an exercise that you have to do. Now coming to the graphs, earlier I think we have studied about charts, and now we are going to learn about graphs. So there is a very nice comparison between the here's an article from the NI that explains the difference between a waveform graph and a waveform chart. So the waveform graph, the way I look at it is like you mostly have waveform graph outside of the loop, and you have the waveform chart inside of the loop. And there is a reason why it is like that, because graph, it will accept only an array as an input. Okay, it will not accept any kind of scalar value, the waveform graph. Whereas the waveform chart, it updates one point at a time. And also this has a feature of accumulating the data in the, it has a buffer, and it keeps storing the data in that buffer. So it has like a memory, and once that buffer is full, it again overwrites on that buffer. So yeah, received in addition this. So mostly we use a waveform graph, and you kind of like plot, you have an array of data and you plot it directly. So you can go in detail between these differences between graphs and charts on the NI website, but it's I think very straightforward that the chart is it stores it updates every single point in the iteration, whereas waveform graph, it acquires one array as a whole and then plots it all together at once. And in chart, you have this concept of buffer and history. Whereas in waveform graph, you don't have anything like that. And so the starting x value and the step size in the case of waveform graph will be 0. Like the x value starts with 1 and the interval will be 1 by default, but you can change it by going into the settings, can change the properties. Yeah. So coming to the graph, so even in graphs, there are two types of graphs. So there are XY graphs and the waveform graphs. So in waveform graphs, you just have like an array values like Y values, and which are plotted with the default time values or X values. But in the case of XY graph, you specifically have like certain X values and which are plotted against the Y values. And so you have to give like generate two different arrays. So this is single plot waveform graphs. So you can just generate an array, 1D array, and connect it to the waveform graph to get a plot all together at once. And then we also have like a bundle function that will help you. I know we were using like bundle earlier to do like multiple plots in a chart. But you're using a bundle function here to change the values of the initial values of the x and the interval between the x values. If you want to change it, then you can use this bundle function. The way you access is by just going here. Yeah, you have to use the bundle function here. Just go to cluster and use it. Coming back to the manual. Yeah. So you can change the initial values and the delta x either using the bundle function or by or by just going onto the front panel and then right clicking here and changing the you have like properties. I have shown you in the last lecture how to go into the settings and change the values, like so you can do even from there. Now, if you want to do a multiple plot waveform graphs, then you have to use the build array function. So if you want to do a multiple waveform graphs, then you use something called build array and you create a 2D array here and then plot it on the waveform graph. Then next, if you want to change the initial values and the delta x value, you just have to use the bundle function and then use the build array function to generate a 2D waveform. I think this is a very good example. Now here we are going into the XY graphs. These were the waveform graphs so far that we were dealing with. You just had like Y values plotted against time axis. But in the case of XY graph, as you can see here, you have an array for X. There's an X. There is a um, so you have like an X array and which are plotted against Y array. So you can use the bundle function again here and then send it to the XY graph. This is an exercise that you have to practice. It has all the steps here. So then our next topic is on clusters. So we saw previously, like we were using the bundle function with charts and graphs, and that is used to group information for the plots. The bundle function creates a data type in the lab view known as the cluster. So cluster is nothing but a data structure, or it's, in simple words, it's an collection of array of different data types. So like in array, you have usually elements where all the data components are exactly the same. In a cluster, it can be a collection of different data types. For example, it can be a numeric indicator and a Boolean indicator or string indicator, all of them grouped together as cluster. So this is similar to struct in C and record in Pascal if you have learned it before. So here the purpose of using cluster is to avoid a lot of clutter in your data, because there's a lot of wires that if your code is like really big. And so if you have like a very complex code and there are like a lot of wirings, so it makes it look intimidating and not very presentable. So one of the ways is to use a cluster. For example, this is just like you have like different data type wires being they are all present in this cluster. It avoids a lot of errors and confusion. So it's better to use a cluster. So when you have like different data types, you can just create a cluster, and this is a cluster wire. And similarly, if you want to access any of those components, you have like the unbundle function, unbundle the cluster function. So that will help you access the components. So creating cluster controls and indicators on the front panel, I can demonstrate this for you. So we just do right click and go to data containers and then go to cluster. So now this is an empty shell, but you can have either an indicator or control cluster. You can't have a combination of indicators and controls. So whatever you drop first into the shell, the cluster becomes of that type. Suppose if I drop an control, then it becomes a control cluster. Okay. Yep, this is how you, and then you can have from the Boolean. This is another control. Okay. Then if we want to create a cluster constants, like I always said you, if you want to create a cluster constant, you always do it in the block diagram. So go here, go to cluster, and then choose cluster constant. And then you can start dropping in different kinds of data types into this. So I want to create a cluster constant. For that, I need to drop some constants in this. So I'm going to drop a numeric constant here, and might drop some Boolean constant here. Can drop some string constant here. Yeah, so this is a constant. Okay. Yeah, and the next topic is, okay, we have learned how to create a cluster constant. Yeah, the cluster order. So the cluster order, the order of the cluster is very, very important. The order of each element, like just you have the index number for each element in an array, you also have something called cluster order in a cluster. So it's very important to know the order of each component in a cluster if you want to manipulate the data in it, or want to connect it to use it as a part of your code. So when LabVIEW manipulates clusters of data, the data types of the individual components within the cluster and the order of the components in the cluster are both very important. Cluster components have a logical order unrelated to their position within the shell. The first object placed in the cluster shell is the component 0. The second is the component 1, and so on. If you delete a component, the order adjusts automatically. So let's say this is our, it doesn't matter where you place them, but in the order in which we have added them gives them the order. Okay, I want to use a different kind of string control. Okay, and another. Okay, so now if you want to view the order of this, which is component 0, component 1, just right click, let's go to this, right click, reorder controls in the cluster. As you can see here, this is the component 0, this is component 1, this is component 2, and this is component 3. If you want to change the order, you can just right now click to set 0. So if, select the component which you want to be, whose order you want it to be 0. For example, I want the Boolean to be my first component, so I can select this. So now the black one is the current order, is the current order numbers, and the white one is the old one, the previous one. So you can see automatically it gets adjusted. So now click to set to 1. So I want to set this as 1. So now it's updated to 1. So this order is really important when you are working with the cluster to manipulate the data. So this is all about it. And then next, okay, it's gonna click this. using clusters to pass data to and from the sub VIs. Now this is very important. We have created a sub VI earlier, and we know that a VI connector pane can have a maximum of 28 terminals as shown in the figure below. When you use a connector pane that has a large number of terminals, the terminals are very small and it becomes very difficult to wire. For example, here it's very difficult to wire. It is best to use a connector pane with 14 or few terminals. So you can use cluster to group related controls together. Like for example, in this one, instead of having like a like having something like this with a lot of wiring, what you can do is you can go to your sub VI and create a cluster of all the controls, and then create a cluster of all the indicators, and then yeah and then you can just even give input in the form of a cluster here. So it becomes very, very clean, and there is less like it doesn't make your code look very complex, and it makes your code looks very very presentable. So if you use a cluster, not that you can even work without the cluster, but the goal of using a cluster is to just make your code look more sophisticated and organized. And then there is something called, if you want to create a cluster, then you can use the bundle function by just going to the functions palette and just going to the cluster palette and choosing the bundle option. So you can connect all your components here and get an output as a cluster. And also the same function bundle can also be used to change any of the components of an existing cluster. Let's say we have like I have a cluster 1 which is connected here, and you want to change one of its component. So say you want to change the component 1 in it. All you have to do is wire up it to the value which you want to update it to, and then connect it here. So it will automatically give an updated version of your cluster at the output. Like you have like an input cluster. So you want to update, you can see here, this is your input cluster, and you have this command which has like volts, AC, and you want to change it to new command ohms. The way you do it is, and this is your output cluster, this is how you want it to be. So the way you do it is you use the bundle function, give your connect your input cluster here, and then connect your new command, and then you get like an updated output cluster. Then there is also like bundle by name thing, and so you can even bundle them by name. Bundle by name works similarly to bundle function, but instead of referencing cluster components by their cluster order, it references them by their own labels, which I just told you about the own labels. Like for example, constants, they don't have their own labels. You have to assign a label to it. So so you can even access them through their labels also. So you call it like bundle by name. Yeah, so you can choose the bundle by name and then right click and choose which one you want to change. Like for example, here we want to change the command to the new command. So you can select it from here. And disassembling the cluster, you can use the unbundle function. Okay. So you can access each component of it, and you can use the unbundle by name option also if you want to access through the names and if you don't know the order of it. So this is like an input cluster, and then you use unbundle, and you can have like an indicator for each of them. And in unbundle by name, just note that like it doesn't have the same number of. So notice that when you use the unbundle by name function, you can have an arbitrary number of terminals and can access specific components by name in any order. So so it's recommended to use the unbundle function than unbundle by name function. And then in clusters also you have polymorphism. You can perform different functions, like you can multiply, like for example in this case they are multiplying each of the control by a scaling factor. So you can perform operations on the cluster as well, and you can convert a cluster um, from number to fractional string as well. And here's a simple exercise that I can demonstrate. So that will help you understand the concepts a little better related to cluster. Otherwise, cluster is very, such an easy topic. So here it is. I'm going to demonstrate. I'm going to demonstrate exercise 5 to you. So we are first going to create a cluster. So I'm going to drop a cluster shell here, and I need another one. So this is labeled as modified cluster. Yeah, this is our cluster. And then we have control. So this has all the controls, and this has all the indicators. Like I told you before, a cluster can have either just controls or just indicators. It cannot have a combination of both. So I'm going to drop here a control, a numeric control here. And okay. Then in the Boolean, I'm going to have like vertical toggle switch, 2 of them. And then I'm going to have a slider. So this is the control part. Now this is the one with all the indicators in it. I'm going to drop a numeric indicator here. Then drop Boolean vertical toggle switch. Now this is no longer a control, this is just an indicator. Then gonna have a slide here. So we want to perform some operation here and see the updated version in the modified cluster part. Now apart from that, they want us to drop a stop button. Yep. Then we are supposed to have a numeric indicator. And then a Boolean LED. Yep. And then we need to have another cluster with, it's called the small cluster. Then I am to have a Boolean switch. Oh, it's showing me as a numeric control. So need to first so you just saw, even if I try to put an indicator, it doesn't accept. So I'm just going to delete this and first delete this. This is name as just write slide value. And now my switch will behave like an indicator. Okay, and then we need to reorder this. So let's check the order of this. So based on the example, this is supposed to be 0, 1, 2, 3. Okay, cool. but they want this to be 0. So I click this as 0 and this is automatically set to 1. Okay, click, right click. And then now is the time to code. So they have taken this cluster and our input cluster, and then we have used an unbundle function. So I can resize this. So I'm going to unbundle this cluster, connect this here. So automatically it unbundles. Now the first operation that we want to perform is we are going to unbundle and display what is going to be our numeric value in this. What is the numeric value in the cluster, and what's the Boolean value. So you're just gonna indicate it using these indicators. So that's numeric when we hover over it. So I'm just gonna connect it here. And now when I hover over it, it's Boolean here. So I'm gonna use the second Boolean. Okay. So this will show me the output, what's inside of it. And then this is going to be my small cluster. I want to see the rest of the values in the form of a cluster, the small cluster. So if I have to indicate it in the form of cluster, then I need to use a bundle function. Okay, so I'm gonna connect this here. Slide value here. And then connect it here. Okay. This is bundle. So now you saw that it is not having its own label. So that means it doesn't have an own label. You can use the tools palette and use the text box to generate the labels for each of them. But these icons, they have an own label. Okay, so we can then view what is inside of this small cluster and what's the value of the numeric and the Boolean here. Then the other thing that I want to do is I want to manipulate the values of the numeric and the Boolean. So what I'm going to do is use the unbundle by name option. Giving it's my input. Can I expand it to see all the components by name? And then what I want to do is increment the numeric value. So can I increase by 1? Okay. And then the Boolean value, I want to use a NOT gate for it. And then I want to, I have manipulated internally. Now I just want to update it. This will be my output. Now I'm going to use the bundle function. If I want my output to be in the form of a cluster, so I'm going to use bundle by name. Okay. And then the output should be connected this way here. And as you can see, then you can resize it. So numeric goes to numeric. Boolean goes to Boolean. And this is connected to the modified cluster. And also they want us to run this in a loop. So for that, we just go to structures, while loop. Okay. Connect this button here. Okay, so we are done. But wait a second, it shows me some errors. Okay. So here, so I'm just going to reduce the size of it because these are the two things I want to update in the existing cluster. And the updated, the modified cluster will be here. Okay, so the initial value I'm setting here is 2, and I'm expecting that it should be incremented by 1, and it should display me 3 here, and the Boolean is in an on position. So I expect it to see in an off position here. And I'm going to set the slide value here. And the Boolean here, Boolean 2 is supposed to show me whatever value is there. It's say is passed on the same, it's going to be on, and the slide value should also be the same. It's about 3. Yeah, and then I expect to see 2 here, and the Boolean is connected to this. So this is supposed to be on. So this is what I expect to see. So let's run this. Yeah. So this cluster is showing me the small cluster is showing me the values of this as it is. And the Boolean value, which is being from this is on, this is on. Yes, this is correct. And it's showing me the numeric value as it is. This is showing me an on position as it is. And the modified cluster, yeah, it's incrementing by 1. Yes. And then the Boolean is showing the not of it. Yes. And then the Boolean 2 is passed on as it is. Yes. And the slide also as it is. Yes. So like that, we come to know that it's working perfectly fine. I'm sorry, I should have used this button to do it. So never mind. Then, so now we have learned about clusters, how we can create clusters, how we can view the data inside the clusters using unbundle and bundle functions, and how you can manipulate the data inside the clusters and then display it again in the form of clusters. So it's just, it just simply boils down to unbundling and bundling. So, And there is one more exercise on clusters which you can do. It's very straightforward. Thanks for paying attention. And next class will be a very easy one. I think this one was the only tough part. And yeah, good luck, and let me know if you have any questions via email. Thanks for listening.